Hello, I'm going to go through part I of question 1 on the 2013 math paper. So in this question, was a recursively defined function f. So they tell us that f of 1 is 1, f of 2 is 1, and f of 3 is minus 1. And then they define f of 2k is f of k, and also f of 2k plus 1 is equal to f of k. And they want us to find out what is f of 1 plus f of 2 plus all the way up to f of 100. So the easiest way to see what's going on is to just try a few numbers in and then see if we can see any sort of pattern. So we see that f of 1 and f of 2 and 3 have all been defined, and that's 1, 1 and minus 3. Minus 1. And now because of this recursive definition, then f of k is going to be finding 2k and 2k plus 1. So after 3, then for an even number and the consecutive odd number, then they're both going to be the same. So once we get to 4 and 5, they're both going to be the same as f of 2, because f of 4 is 2 times 2 and 5 is 2 times 2 plus 1. So if we use these formulas, we see that these two are both going to be 1. And then we see that once we get to, so 2 times 4 is 8. So 8 and 9 are both going to be defined by 4. But also 11 and 10 are both going to be defined by 5. And these were both defined by the same thing, by 2. So we're actually going to get 4 numbers that are the same here. And then if we looked at the numbers at 16 and afterwards, well, we're going to have 16 and 17 both defined by 8, and then 18, 19 by 9, and so on. So we'd actually get 8 ones in a row there, and so on. And also we see that, okay, so 6 is 2 times 3, and 7 is 2 times 3 plus 1. So we have minus 1, minus 1. And when we get to 12, 13, 14, 15. So 12 and 13 both defined by 6 as 6 plus 1 is 2 times 6 and 2 times 6 plus 1. And then 14 and 15 is 2 times 7 and 2 times 7 plus 1. So these are all going to be minus 1. So we're going to see that the pattern that we get is we have, okay, so 1, 1 and 1 minus 1. Then we have 2 1s and 2 minus 1s, then 4 1s, 4 minus 1s. And if we carried on, we'd get 8 1s, 8 minus 1s, 16 1s, 16 minus 1s, and so on. So we get groups of 1s and minus 1s, and the number of 1s and minus 1s doubles each time. So now we know what's going on. You can use this to our advantage, because we see that, well, we get groups of 1s and then minus 1s, but it's the same number of 1s and minus 1s each time, right? So we're going to have that this, when we add up f of 1 plus f of 2 plus so on, we're going to get that, well, f of 2 and f of 3 cancel, f of 4 and 5 cancel with 6 and 7. So we're going to get also these terms cancelling. So the only terms we have to add up are, well, the 1 from 1 here, and also any 1s or minus 1s we might have at the end that haven't cancelled. So how many 1s and minus 1s would there be at the end? Well, okay, let's try and add these up. So here we have a group of 2 numbers that cancel, and then we have a group of 4 numbers that cancel, and then we have 8 that cancel. So the numbers that we get cancelling, so we're going to get 2 that cancel, and then 4 that cancel, then 8 that cancel, and 16 that cancel, and just keep track of how many numbers we've had so far. So far we've got 30, so then we have plus 32 numbers cancelling out, so that's going to be 62 in total. And then after this we would be getting the next 64 numbers cancelling themselves out, so we'll have 32 1s and 32 minus 1s. But if we look, then we've got more than 100 numbers that we've counted up so far. So less than 100, we're only going to get this many numbers cancelling out, and this is equal to 62. Okay, so what we've basically worked out is that we've got 1 from f of 1, and then we have 62 terms that cancel themselves out. And then after that, we're going to have 32 ones and 32 minus ones, but we're only looking for numbers less than or equal to 100. So actually, once we've taken in this first one and the 62 terms, we've only needed 27 to get to 100. So that means we only need the first 27 ones. So we're adding on an extra 27. So we've got 1, then everything in the middle cancels out, then we're adding on an extra 27. So we have total equal to 1 plus 27 is equal to 28. And so our answer is B.